precise meaning of the term cognition remains elusive. This sentence comes from the 2021 edition of Principles of Neuroscience, a major textbook in this subject. The same is true for the mind, emotions, and intentionality. Even though these concepts fascinated people ever since the dawn of civilization, the first answer came to the question, what is the mind, from the religious understanding of God and the belief in afterlife. Perhaps a more objective consideration came from philosophy. For example, dualism states that the mind is very different from the brain. The brain can be located in the skull, but the mind cannot be located in the brain or anywhere else. It doesn't have a length, height, weight, or any other property that we associate with things. Nevertheless, neuroscience have established that the brain gives rise to the mind. And physical principles have been suggested to explain behavior and social phenomena. When the new physics, quantum mechanics, was born, its first practitioners were heavily influenced by philosophy and psychology, namely Wolfgang Pauli and Bohm. And many physicists, even later, were thinking that there was a residual consciousness in particles such as the electron. Freeman Dyson, the mathematical physicist, thought that quantum mechanics was a type of decision-making. But maybe we have to think about it the reverse order, because the living system, the brain, is embedded in the physical world. Its constant interaction with the environment requires an intuition of the environment and its physical laws. So the brain projects this physical environment into some mental world that in the most intelligent animals develops a particle-like regulation, quantum cognition. Decades-long literature supports the idea that the mathematical formalism of quantum mechanics can explain human behavior and social behavior. A good representation is the Necker cube, which is a cube without spatial clues. But in the mind, we can only perceive a three-dimensional representation, because either the lower left or the upper right corner moves forward in perception. More than that, there is a quantum-like fluctuation between the two possibilities. And the same can occur with other sensory perceptions, such as the two nostrils. Emotions have also been studied lately using physical methods. If emotions are represented with colors according to their basic qualities, such as confidence, in self-assertiveness, then it is found that emotions diffuse on social media among users like colors in a liquid or heat. This indicates that emotions are energy carriers, like the photon. To investigate further the energy nature of emotions, we can look at imaging. And it is found that each emotion has a characteristic activation profile in the brain. More than that, negative emotions and focus states correlate with greater frequency activations and have greater energy needs than positive emotions or neutral states. So, emotions can be considered the polarities of the brain's operation. The brain, without any task, forms a so-called resting state. This is a low-frequency, spontaneous activation, oscillation between functionally related regions. And between the active and the resting brain, we can form an energy cycle. So, if we represent this quality with a spring, then we could use the spring in equilibrium to represent the resting state, and negative emotions would correlate with a compressed spring, and then expanded spring would be positive emotions, and the force to recover the resting state would correlate with motivation. So how can we imagine this in practice, this energy cycle in the brain? Well, the first law of thermodynamics says that energy cannot be created or destroyed. It can just transform from one form to another. In the 1960s, Landauer, who worked in computation, realized that information must be considered as well, because that is an energy consequence of computation. And of course, the brain is an intelligent computing system. So the brain's activation can be viewed as a thermodynamic cycle. Information input unbalances the brain, resting state, and as the resting state recovers, some energy level of the brain has to change, which is synaptic complexity. So the initial state and the final state, the final resting state, differs. And this leads to memory, allowing a better response in the future. This is the basis of the temporal orientation of the brain. To look at this temporal nature in more detail, we can see that the mind is an orthogonal transformation from the brain. It's a temporal but non-material structure. And we recognize that this is where the dualistic understanding came from. But where did the religious belief in the soul come from? If we consider particles during entanglement, there can be infinite distance between sister particles. So the particles' quantum wave have a infinite expanse. Likewise, the mind forms a quantum wave, and our emotions and our beliefs have the sense of infinity associated with them. This is also the origin of our difficulty to accept death, and perhaps that gave rise to the religious belief in afterlife. Now we can answer the question, what is consciousness? Consciousness is the awareness of the mind's separate observer status over the self-regulating brain. The self-regulating brain that always recovers the resting state. And the brain is just a projector of sensory reality into an abstract mental world. And now we can see and discovering quantum mechanics in consciousness shows the mind's fundamental coherence with the physical world. Physics is the exclusive organizing principle of the astonishingly coherent cosmos.